Hello dear students, I welcome you all to my channel. So today we'll see the second video on mathematical reasoning. So far if you have not understood anything, then you can go and have a look at part 1 of the mathematical reasoning video and again get back to this particular video. So the link for the part 1 will be given in the description, so kindly go and visit your part 1 video. So in today's lecture on mathematical reasoning, we'll learn about something called negation of compound statements. So the statements which has and, or, word or. Okay, so if any of these are there, then such kind of statements are called compound statements. So we are going to see the negation of such statements. So next, first one is negation of conjunction. Okay, so conjunction means and, yes. So there is a statement, okay, which is connected with and, okay, and you want to take the negation of that. So this will be equals to this one. All right, so this is one of the very important formula which will be useful in one of the very important chapter called sets as well. All right, so this is one of the very important formula here. So this is the negation of conjunction. So next is negation of disjunction. Okay, so disjunction means statements if they are connected with or, so then the such kind of statements are known as disjunction. Okay, so we have P and Q which are joined by or. Okay, so if you take the negation of such statements, then your answer will be somewhat like this. Okay, and these two formula in a combined way, they are also known as De Morgan's law. All right, okay, so the third case is negation of negation. Okay, so this is pretty straight. So if you have got some statement, you have put not over there. Okay, so the not of not will always be positive, right? So we will have negation of negation P will be equals to always P. All right, okay, so you may pause the video to note down these three important formula. Okay, okay, so the next thing that we are going to learn here is quantifiers. Okay, so quantifiers, as the name itself suggests, it is going to tell you about the quantity. Okay, so whether the amount is more or less, so that's what the quantifier is going to tell you here. Okay, so the first thing that I want to say here is quantifiers are nothing but the phrases like there exist or for every. So there exist means it's a less amount, for every means it's a big amount. Okay, so that's why these phrases acts like your quantifiers. So it's going to tell you the quantity. All right, so there are two kinds of quantifiers. So first one is known as universal. So universal means it's a huge, universal, right? So it's a huge means here you are going to use for every. Okay, and symbolically you write universal quantifier as ulta a. Okay, so this is called universal quantifier. Okay, so when you read this, you have to read it as for every, or else you can use for all, or else you can use for each. Okay, or a similar equivalent phrase. All right, the next one is known as existential quantifier. Okay, and this is written as ulta e. Okay, and this is read as there exist or there is at least one or something similar. All right, so most often you need to remember this part. Okay, so there exist, this is there exist is followed by this particular symbol. Okay, and this meaning of this symbol is such that. Okay, so you need to remember this. So whenever you have got there exist, such that comes as free. Okay, so you need to remember this thing here. Okay, and here let us try to understand what will be the negation of quantifiers. Okay, so what you need to remember is negation of universal quantifier will always be existential quantifier, and the negation of existential quantifier will always be universal quantifier. All right, so you may pause the video to note down these many important points here. Okay, so let's have a look at the problems, that is exercise 3.4. So whatever we have learned just now, that's not going to be useful in this particular exercise. Instead, what we have learned in our first video, that will be useful in this particular exercise. Okay, so question says, write the component statements of the following compound statements and check whether the compound statement is true or false. Okay, so here if you check, in every sentence or in every compound statement you will find there's a word and, right? So here also and, there is also and, there is also and here also we have got and, here also we have got and. All right, so since this is a compound statement which contains and, so let us make use of this particular truth table for and. All right, so we'll make use of this in this particular case. Okay, so first we need to write the component statements, that is P and Q. Okay, so the first one says a line is straight and extends indefinitely in both directions. So if I ask you to separate this into component statements, then you write this as P, a line is straight. So another is a line extends indefinitely in both directions. So this becomes my statement Q. Okay, so these are two component statements. Now let us check the compound statement is true or false. Okay, so that means we are going to check whether this is true or false. So in order to check whether this is true or false, let us check what happens to our P and Q. So let us check whether P is true or not. A line is straight. Is this true or false? This is always true. Okay, so P is true. So true means either here or here. Okay, so next is Q. A line extends indefinitely in both the directions. So this is also true, we know that, right? So that's why P is also true, Q is also true. So both P and Q, if both are true, then what happens to the compound statement? It becomes true. So that's why the question number one is my true. Okay, so P and Q is also true, that is this compound statement is also true. Okay, so I am going to take one more sum for you, so that is 2. So 0 is less than every positive integer and every negative integer. So when you break this into two simple statements, the statement becomes 0 is less than every positive integer, 0 is less than every negative integer. Okay, so let us see what is happening here. So 0 is less than every positive integer, this is true, right? But 0 is less than negative number, this is false, right? So one of the statement is true, other one is false, right? So true and false. So if one is true and other is false, then my result will be false, right? So that's why this sentence 2 or statement 2 is always false. All right, so you will try number 3 and 4 by yourself. So let us observe 5. So 5 says a mixture of alcohol and water can be separated by chemical methods. Now just think whether you will be able to break this into two simple statement or not. Okay, so my answer will be you will not be able to separate this, although there is a word and, but they are talking about the mixture, right? So because of this mixture we cannot separate this into two statements, simple statements out here. All right, so that's why we cannot talk about number 5 about the truth value of sentence number 5 here. All right, so you may pause the video to note down. Okay, so similarly we have got the statements which contains or, except the fourth one. All right, so I'm leaving fourth one for you. I'm taking just two questions from here. Okay, so again, since here we have got or, so let me take truth table for or. All right, okay, so number 1 says root 2 is a rational number or root 2 is an irrational number. So I have broken them into two simple statements. Number 1 is false, root 2 is a rational number is false, root 2 is an irrational number, this is always true. Okay, one is false, other is true. So my result will be, let us say, false, true or false. So if one of them is false, then still my answer will be true, right? So that's why this compound statement is true. Okay, so let me take number 2. So 125 is a multiple of 7, 125 is a multiple of 8, right? Okay, so here both are actually false, right? So this is also false, please remember this. So this is also false. So when both are false, then my answer will be false. Okay, so please make correction here. This is not true, this is false. So when both the statements are false, then only my result will be false. So that's why this is also false. All right, so you may try 3 and 4 by yourself. So you may pause the video to note down. Okay, so the next thing that we learn here is inclusive or exclusive or. So let's try to understand what is the meaning of inclusive or and exclusive or. Okay, so let us take P and Q be two statements. Okay, and we are taking a compound statements which connects P and Q using or. Okay, so we are going to talk about this particular compound statement. Now if P and Q both are true at the same time, okay, then this kind of statement where there is a or, then this kind of statement is called inclusive or. Okay, now if out of P and Q any one of them is true at a time, okay, so both are not false, please remember that. So any one of them is true, then such kind of or is known as exclusive or. All right, so if you have understood this, let us go and understand this kind of sum. So you need to identify the type of or, whether this is exclusive or inclusive, used in the following statements. Okay, so Ratan is corrupt, and another statement here. So if this is your P, then another statement becomes Ratan is honest. Okay, so corrupt and honest. So if he is corrupt, then he cannot be honest, right? So that's why this has to be exclusive. All right, so one of the statement is true at a time, right? Both cannot happen at the same time, so that's why this is exclusive or. All right, Mahesh is obedient or Mahesh is honest. So Mahesh can be obedient and honest at the same time, so that's why this is inclusive. All right, Richa is truthful and or Richa is punctual. So both can happen at the same time, so that's why this is also inclusive. Okay, so the last part is Subhash believes in violence or non-violence. So both of these cannot happen at the same time, so that's why this is exclusive or. All right, okay, so let's see the next question. Question number 5 from exercise 3.4. Translate the following into symbolic form. Okay, so again here you see that there's and used here, or is used, right? Similarly here or is used. So basically what you need to do here is you first divide this compound statement into its component statements. For example, 1, 2 and 3, I have just divided all this into component statement. For example, the first one can be divided into Rahul passed in Hindi and another will be Rahul passed in English. Okay, so this is my P and this is my Q. Now P and Q is connected using the word and, so that's why this in symbolic form can be written as P and Q. All right, okay, similarly this can be divided into two component statement. P, that is x is an odd integer, another is Q, such that x plus 1 is an odd integer. All right, okay, so these two statements have been connected using or, so that's why this becomes P or Q. Okay, similarly we have got the last one which is connected by or, so again this will be connected using P or Q. All right, so this will be the symbolic form of this. Now you cannot just write P and Q, you have to state what is P, what is Q, which is clearly stated in this way. All right, so you may pause the video to note down. Okay, so the next question is about identifying the quantifier. Okay, so we have learned two types of quantifier, one is universal and another one is existential, right? So for every means for all, that means this is universal. There exist means existential, there exist again existential. For every means it is universal, right? So this is very simple here. Now next part says write the negation of the statements. So this is given to you, okay, and you have to write the negation of this particular statement. Now since there is universal, right, now the universals negation will be existential, right? So instead of for every, there will come there exist. Okay, so there exists a prime. Okay, so the first one will be there exists a prime number p such that, okay, as I said earlier, whenever you write there exists such that should come as free. Okay, so there exists a prime number p such that, now here root p is a irrational number, right? So what is the opposite of irrational? Root p has to be rational number. So this is your negation of first one. Okay, let us check the next one. Existential is there, so the negation of existential becomes universal. So basically you have to write for every, for all, whatever you want to write. Okay, so here we have there exists a number which is equal to its square. Okay, so the negation of this can be written in this way. Okay, so next is there exists a capital for every state in India. Okay, so there is at least one state. Again, the existential is there, converted this into universal. So this says there exists at least one state which does not have a capital. Okay, and the last one is for every real x. Okay, so this is a universal. Its converse, I'm sorry, its negation has to be existential, right? Okay, so there exists a real number x such that x is not less than x plus 4, right? So this is the negation of this particular statement. Okay, so you may take few more statements from your solved examples and check whether, or check how to find the negation of the given statement from your solved example. All right, so you may pause the video to note down. Okay, so the next topic for the day is conditional statements. So let us try to understand what is the meaning of conditional statements. So if P and Q are any two statements, then the compound statements if P then Q formed by joining P and Q by a connective if then is called conditional statement or an implication. Okay, so conditional statement is also known as implication. So basically you have got two statements P and Q, okay, and this time you are not joining them using and or like that. Okay, so this time you are joining the statements P and Q using if then. Okay, then such kind of statement is known as conditional statement or an implication. Okay, so symbolically it is written as P, and we all know the meaning of this. This means implies. Okay, so in your book you may find only single line like this. This time I am showing you double line. Both means the same. All right, so you need to remember this particular thing here. Okay, so here this P is called antecedent or hypothesis. Okay, and Q is known as consequent or conclusion. Okay, so the next thing that you need to learn in this is the different styles of this. Okay, so P implies Q. If P then Q can be written in these many 5 different ways. Okay, so P implies Q means if P then Q, all right, or else in other words you can say Q if P, okay, P only if Q, P is sufficient for Q. Okay, so P is sufficient for Q and Q is necessary for P. So whenever you see Q is necessary for P, this means P implies Q. All right, so these are the 5 different styles of representing P implies Q. Okay, so you need to memorize this by yourself. Okay, and the next thing that we learn in connectives, okay, logical connective, is truth table. So the truth table for this is given by this particular thing. Okay, so you'll see false only if it is TF. If TF is there, then your answer or your result will become F. All right, so on the basis of this, let us have a look at some problems. Okay, so write the following conditional sentence in the form P if P then Q. Okay, so let us try to understand this here. So here we have first question says, so let me read first question for you. So first question says, knowing the question paper in advance is necessary condition for getting grade A. Okay, so if you compare this with the earlier 5 conditions, okay, so knowing the question paper in advance is P, okay, I'm sorry, it's a Q, okay, is necessary condition for getting grade A. So getting grade A comes behind, means this is your P, right? Because we have got in that list, in 5th number, we have got Q is a necessary condition for P, right? So Q is this one and P is this one. So that's why this, in this term, that is if P, then Q can be written as, if you get grade A, then we have to write Q, then you knew the question paper in advance. All right, so this is your answer for this first one. Okay, so you have written this first part in if P then Q format. Okay, now let us go to the next one. Knowing the question paper in advance, okay, so this is my P, is a sufficient condition. So there is a sufficient condition written, so that's why this falls under your 4th category, right? So in 4th category you have written P first, right? So whatever comes first, this is your P. So P is sufficient for Q, so the next part becomes your Q, right? So that's why if I include if and then this particular sentence becomes, if you know the question paper in advance, okay, so as you said earlier, so this is your P, so P came first, then should come Q, right? So then getting grade A, so you get grade A, right? So this is your revised version. Okay, so you have written this in if P then Q format. All right, so you may pause the video to note down this as well. So let's see the third one. So you will fail if you will not study. So if is coming in the middle, so this falls under your second condition, right? So second condition says Q if P. So whatever sentence is there first, so that is your Q. So this is your Q and this is your P. So if you do not study, then you will fail. So this will be your answer. All right. Similarly, fourth one is also same. If is there later, right? So the first one is your Q and the second part becomes your P. So this can be written as, if an integer is divisible by 5, okay, so if an integer is divisible by 5, then its unit digit is 0 or 5. All right. So similarly, you will try the rest by yourself. All right. So you may pause the video to note down. Okay, so having understood the first conditional statement, that is P implies Q, now let us move on to the next kind of conditional statement, and we call it converse of a conditional statement. So in this, what we do is, there's a statement given to you, conditional statement, that is P implies Q, okay, and the converse is represented as Q implies P. Okay, so Q implies P is the converse of P implies Q. So let us try to understand this using some problems. So let me take question number 2 from exercise 3.5. So question says, find the converse of the following statements. So basically here your job is going to be first identify P and Q. Okay, so we have a conditional statement, if P then Q. Okay, so if P, so this becomes your P here, then Q. Okay, so if P then Q can be written as P implies Q, right? And your job is to write Q implies P, right? So we identified Q here, so this will come front and this will go back. All right, so my first answer will be if P, if Q, right? If Q, because Q implies P means what? This means if Q then P, right? Okay, so if Q, okay, then P. All right, so this is my answer for first question. Similarly, let us check what is P and Q for the second part. So for second question, if green little people live on moon, okay, so that means this is my P, then we are descendants from Mars. We are descendants from Mars is Q. So first we need to write Q. So that's why if we are descendant from Mars, then green little people live on moon will be my answer. Okay, similarly, let us see the third one. So if I slap you, then you will cry, right? So if I slap you is my P, right? I slap you is P, you will cry is Q. Now you will cry has to come front, but you have to arrange your sentence as well. Your sentence should have some meaning, right? So that's why this changes to if you cry, then I will slap you. Okay, so this is my answer. Similarly, you can check your answers with 4th, 5th and 6th. Okay, so these will be your answers. Alright, so you may pause the video to note down. Okay, now let us move on to the next kind of conditional statement, and we call it contrapositive of a conditional statement. Okay, so there's a conditional statement given to you. Now the contrapositive means first take the negation of each statement. Okay, and this statement, okay, so this statement is called your contrapositive. Now in order to understand this, let us see some examples. Okay, so here you have to write equivalent contrapositive form. So again, as you can see, you first need to identify P and Q. Okay, so as usual, we'll identify P and Q and we'll take the negation of those. All right, and negation Q comes front and negation P goes back. Okay, so that's what you need to do. Okay, so let's have a look at the first question. So question says, if the physical environment changes, then the biological environment changes. As usual, we'll identify our P and Q here. Okay, so if the physical environment changes, so the physical environment changes is my P, then the biological environment changes. So the biological environment changes is my Q, right? So when you write contrapositive, you have to change the, or you have to find the negation of P and Q. So the negation of P becomes the physical environment changes, becomes the physical environment does not change. Okay, and the biological environment changes. The negation of this will be the biological environment does not change. So the statement, contrapositive statement becomes, if the biological environment does not change, then the physical environment does not change. Okay, so this becomes my contrapositive of first statement. Hope the thing is clear to you. Let me take one more sum for you. So if the moon is not square, okay, moon is not square is P, then the earth is not round. So the earth is not round is Q. So what is the negation of Q here? Earth is not round. So the negation of this becomes earth is round. So if earth is round, then moon is square. Okay, so that's what will be my answer. Similarly, you can check your answer with 3, 4 and 5. Yes, okay, so these will be your answer for this 3 statements. All right, so you may pause the video to note down here. Okay, so let's see the next type of conditional statement, and we call it biconditional. Okay, so basically biconditional is nothing but you combine a statement. Okay, so that is a conditional statement. That means if you combine P implies Q with its converse, that is Q implies P, then such kind of statement is known as biconditional statement. And this time we use this arrow. All right, so this arrow is also known as if and only if. Okay, so in short form sometimes you may see IFF as well. So IFF is also if and only if. Okay, so here you need to learn one more table, that is truth table, and this time truth table will be somewhat like this. That means if both are false, then my answer will be true. If both are true, then my answer will be true. Otherwise my answer will be false. All right, so let us see few examples for biconditional statements. Okay, so here given below are two pairs of statements, you can see here. So combine these two using if and only if. So it is given, if a rectangle is a square, then all its 4 sides are equal. Okay, another is, if all 4 sides of a rectangle are equal, then it is a square. So basically what is happening here, both are converse of each other, right? So if I have to combine these two using if and only if, I can say a rectangle is a square if and only if all its 4 sides are equal. All right, so that's what will be my answer for this particular question. Okay, now let's see the next question. So question says, if the sum of the digits of a number is divisible by 3, so this becomes my P, then the number is divisible by 3. So the number is divisible by 3 is my Q. All right, so let us combine these two. So P and Q. is already there, and we need to write this as biconditional. So let me go back to the earlier slide where I have forgot to mention you one thing. So this, how to read this, I'll tell you about this. So this is read as P implies and implied by Q. Okay, so let me repeat it once again. P implies and implied by Q. So this is how we need to read this double arrow. All right. So here also we have got, this is my P, this next part is my Q, right? So P implies and implied by Q can be written as, see, the sum of the digits of a number is divisible by 3 if and only if the number is divisible by 3. Okay, so that's what will be my answer for second part. All right, now let us see the last part. So last part says a natural number is, a natural number n is odd. Okay, natural number n is not divisible by 3, not divisible by 2. So you need to combine these two, right? So how to combine? A natural number n is odd if and only if it is not divisible by 2. All right, so this will be my answer for third part. All right, so you may pause the video to note down. Thank you very much. Okay, so if you like the video or if you understand the video, kindly give a like to the video. Thank you very much.